Okay, how do we solve quadratic inequalities using a table, and how do we solve them algebraically? Well, these are graphs of quadratic inequalities. And if we look at all of this shaded area is the solution region. So what we're going to do today is we're going to focus in on just the x-axis and treat the x-axis like a number line. Okay, so if I'm only looking at the x-axis, the solutions for this first graph are over here and over here. The solutions for the second graph are trapped in between those 2 points. These points that cross the x-axis, these are my critical values, and we're going to talk about those in a minute. But if I wanted to write an inequality for just the x values that were solutions for this first and second graph, in this first graph we noticed that the solutions would be split from -2 into the negatives and from +2 on. So this is an OR situation. All of my solutions happen whenever x is less than -2 or when x is greater than +2. We know it's just less than because it's a dashed graph, right? So this is all from graphing quadratic inequalities. On the second graph, all of my solutions are trapped in between those two critical values. So all of the x's are either greater than -2 or less than 2. So -2 is less than x, and x is less than 2. Okay, let's look at how to solve a quadratic inequality using a table. My very first step is that I want to change this to x squared plus 3x minus 4 is less than or equal to 0. Because in a moment, I'm going to find all the values that are less than or equal to 0. Alright, so we have a lot of x values in this table. We need to know the y values because we're looking for whenever they're less than or equal to 0. So all I have to do is replace the x values with the values in the table. So I have, when x is -5, I have -5 squared plus 3 times -5 minus 4. That's 25 minus 15 minus 4, which is 6. Again, -4 squared plus 3 times -4 minus 4 is 0, and so on until we fill out the table. Alright, so after filling out a few points, we have -4, -6, -6, -4, 0. We notice that the pattern starts repeating in the opposite direction. So we can see that this is a positive x squared. So this graph opens up. So it has a minimum. So the graph, let's visualize it. All these y values for a little while were going down. We hit a minimum, which is somewhere in between -2 and -1 at -1.5, and then it starts going the other way. And so it just reflects right over the axis of symmetry, so the y values are going to repeat. So this would be a 6. The most important points are whenever we cross that x-axis. So at the x-axis, the y values are 0. So at 1 and -4, so -4 and 1 are critical values. Critical values. Now I need to look from those points, where can I find all the values that are less than or equal to 0? Well, all of these all of these numbers right here are all less than 0 because they're all negative, right? And or equal to, so I can include my my critical values. So my answer is going to be, well, -4 is less than or equal to x, and all of these x's are less than or equal to 1. So just like on a number line, our shaded region is trapped. So the x's are trapped between our critical values, -4 and 1. The reason that we have this or equal to is because our original inequality was or equal to. X squared plus 2x is greater than 3. What's the first step?
Move over 3. Get everything on the same side. Move over 3.
Yeah, move that 3 over. So x squared plus 2x minus 3 is greater than 0. So I'm just going to plug in these values.
Why is it always so long? Like, why can't we just do like...
Okay, so we're going to go through the same way. Plug in the x values. So negative 5 squared is 25 plus 2 times negative 5 minus 3. So 25 minus 10 is 15, minus 3 is 12, and so on. Okay, so we've done a few of them. As we see the y values, 12, 5, 0, negative 3, negative 4, those are all going down, and then they start bouncing the other way to negative 3. Let's just check. I would think that the next number is going to be 0. So I plug in 1 squared plus 2 times 1 minus 3. Well, that's 1 plus 2 is 3, minus 3 is 0. Okay, so I can see this pattern happening again. This would be a 5. What are my critical values?
Negative 3 and 1.
Negative 3 and 1. And even if those numbers aren't included in the solution, will I write those numbers down in the solution?
Yes.
Yes, the critical values always get written down. Okay? But they're not included in the solution because at negative 3 you have 0, and I'm looking for things strictly greater than 0. Okay? In which direction are things greater than 0? Like 12 and 5, those things are greater than 0. And over here, all of these values would be greater than 0. Okay, so I'm looking for all the things greater than 0. This is an OR situation. Now, I can't just start at negative 4. I have to start at negative 3 because even though negative 3 is not included, negative 3.1 is, and negative 3.5. So my answer, or my inequality will say, it's all of the x's less than negative 3, or all of the x's greater than 1. Okay. Now to solve algebraically, it's the same as solving just regular quadratics, but now we have to include a step for, since it's an inequality, for all the other solutions. So the first thing that we're going to do is replace the greater than or less than or whatever sign we have with an equals. So now I have x squared plus x is equal to 12. Now if I'm going to solve that, I can think, okay, I can either solve using square roots, but that'd be hard because I have an x squared and an x. I could complete the square if I wanted to. I could factor it. I could use quadratic formula, whatever. The easiest way to approach it is, can I factor it? And if you can't, then you can go into the quadratic formula and things like that. So to factor, I need everything to be on one side of the equal sign. So the 12 becomes negative. And now I can factor this because x plus 4 times x minus 3 gives me x squared plus x minus 12. Negative 4 times negative 3 is negative 12. Negative 4 plus negative 3 is just 1. To solve, I set each of these things equal to 0. If x plus 4 equals 0, what does x equal? Yeah. And if x minus 3 equals 0, then x equals 3. Okay, so these are my critical values. Okay, my next step is going to be to plot those critical values on a number line. So here's a number line, negative 4 and 3. And if we think back to what we just did using a table, we were looking for all the times that it was either greater than or less than 0, right? So I'm just going to test points and see if they're greater than or equal to 12 whenever I plug in that point for x. So I take my critical values and I test values inside and outside of those critical values. What's a number outside negative 4? Like negative 5. So I'm going to test negative 5. So I'm going to plug that right back into this original x squared plus x and see if it's greater than or equal to 12. So negative 5 squared plus negative 5 is greater than or equal to 12. That'd be 25 minus 5. So 20 is greater than or equal to 12. Is that true? Yes. So this would be shaded, right? But just to be sure, let's test a point inside these 2 points as well. What's inside? Yeah, 0. 0 is right in between negative 4 and 3. So I've got 0 squared plus 0 is greater than or equal to 12. Is that true? No. So all of this would be shaded. Now, if we tested another point on the outside of this 3, we would see that it produces a true statement, but we already know that if it's going to go to the outside, it's going to go to the outside on both sides. So my inequality, well, I also have to decide, are negative 4 and 3 included? Yes, because it's an or equal to, so these are solid. So my inequality is all the x's less than or equal to negative 4, or all the x's greater than or equal to 3. Okay, so finally, for negative 2x squared plus 12x is greater than or equal to 16, I rewrite it as negative 2x squared plus 12x is minus 16 is equal to 0. Factor out a negative 2 to get x squared minus 6x plus 8 is equal to 0. Factor, so x minus 2 and x minus 4 is equal to 0. Set each factor equal to 0. Well, negative 2 doesn't equal 0, so that's not going to affect anything. I just get x equals 2 and x equals 4. Again, these are my critical values, so they get plotted on the number line. 2, 4. Now, I have to find test points, so I'm going to test 0 and 3 and look for things that are true. So negative 2 times 0 squared plus 12 times 0 is greater than or equal to 16. And this is all just 0 is greater than or equal to 16. That's not true. For 3, I can say, okay, negative 2 times 3 squared plus 12 times 3 is greater than or equal to 16. So I have negative 18 plus 36 is greater than or equal to 16. This is 18 is greater than or equal to 16. This is true. My critical values are included because it's or equal to. So I include 2, include 4, and the 3 was true, so everything in between is shaded. This is an and situation, so we have 2 is less than or equal to x, less than or equal to 4.